pues solía ser localizado en la esquina de allá, con la rama de los semáforos pues volteando para su lado, aquí para frenar a los que están en este carril. Pero pues en esa esquina era muy cercano a donde los carros tenían que parar, así que lo cambiaron a la esquina de acá para que pudieran ver mejor y pararan pues exactamente en la esquina de allá.
Okay, so for you to picture this, according to our mothers, on this avenue a few years ago, there was supposedly a traffic light where the light pole is, which made it very difficult for the drivers to see the traffic light, because when they arrived, they ended up under the traffic light. Here's at another angle of the street, so that you can see how far down the cars were from the traffic light, which made it practically impossible to see. So returning to the problem from years ago, we can see how the pink car is already completely out of range to see the traffic light. In a good case, the green car that stopped before the traffic light is the one that will have the possibility of seeing it.
What do we know? A traffic light has a 90-degree angle, and according to the Federal Highway Administration, a traffic light should be positioned approximately between 15 to 30 meters, and a traffic light measures between 4.5 to 6 meters high. What is the correct angle of inclination of the traffic light and the driver's view?
To solve these two angles, we need the trigonometric functions of SOHCAHTOA. We have two sides, 5 meters long from the traffic light and the 10 meters distance between the car and the traffic light. First, we will find the angle of the driver. The only function that has adjacent and opposite is TOA, which is tangent is equal to opposite over adjacent. Seeing the problem from the angle of the driver, our adjacent would be the length and the opposite would be the width. As we solve for an angle, we convert to inverse tangent and multiply it by the opposite over adjacent, which is 5 over 10. That is 26.5. To solve for the angle of inclination of the traffic light, we use TOA again, but now our opposite is the length and our adjacent is the width. We repeat the procedure replacing with inverse tangent and it gives us 63.43.
How do we know if it's correct? The angles of any triangle must be 180 degrees. The example of the traffic light is a right triangle, which means an angle is 90 degrees. So the sum of the three angles should give you 180. And by doing the equations, we know that we are correct.
We conclude that the new position is so much better than the previous one, since the trigonometric procedures greatly influence the street and avenues. In this way, creating a much lower traffic flow and probability of accidents. That's all. Thanks for watching.
Hola. What the? Aquí a una avenida de carros.